2.1 linear systems. So hopefully today you'll have about 20 minutes to work on this. So let's get it done, okay? That means be quiet. Or I could just pull out the Madagascar. Shut up, everybody. Yeah, he does. He's the king, too. That's what's funny. The king is trying to speak. Okay, good.
That's not a good role model to have. Really.
No, it's not. It's just funny. I hope you do.
Gabby, I hope you do too.
I don't want to drop you.
This is going to take forever. I really honestly want to give you 20 to 25 minutes to work on this today, so you can go to homecoming activities. Let's get her done. So we're going to solve systems of equations. One method is graphing. What's the worry with graphing?
It just takes a long time and stuff. You have to make
I
Yeah, it's not exact. Okay, so our worry there would be that we have some issues with being precise. If you are actually doing this in the real world, you're going to want to use the algebraic methods, which I'm going to show you next. No doubt you've all seen them. Okay, we'll introduce some book language to you that you may not have seen. Yeah, substitution, elimination. I'm going to scale this by 5s. So that first one is going to be minus 18. And what's the x-intercept? 18 divided by 4 is 4.5. How should we scale the x-axis? 2 sounds good to me. So the y-intercept of that is 4.5. So there's one line. And then, why do you do that? This line is, the x-intercept is 6 and 2/3. Yep, missed the dots. Okay. Is that very easy to see the exact answer? Okay, so what would a guess be? What would my x value be?
Oh, it's where they cross.
Okay, so 4. 1 or 3, we get, see, here's the problem. 3, 1. How about we take 2 and make it a negative? That's the average. 4 negative 2 is your answer. Fortunately, that's actually the right answer. Just my graphing skills are unbelievable, apparently. No, but most of the time, you know, if it's a fraction or something, you're not going to get a perfect answer most of the time. So be careful there. This is what we would call consistent and independent. This is the book language that some of you, maybe all of you, have never heard. So what?
Confused.
Why or did
How you got
4, -2? That's where they cross. We're looking for the spot that satisfies both equations. If you plug that point in, bam, bam, both of them work. Okay. Okay, so this is book language, consistent and independent. Consistent means there is a solution, and independent means that they are different lines, basically, for that matter. Okay. Okay with graphing? You're okay with graphing linear equations, I know that. Just put two of them together and mark the spot. Okay, we're going to try substitution next. This is algebra.
You just make these problems up as you go, or do you look at them?
You know, sometimes I do.
Do what?
When, like, nice work there. If I don't have a book, I will just make them up. But since I have one, the video from last hour comes straight from the examples you see in your book. Your video that posts online is actually examples that are in my book that are not in yours. So I show, if you want to go look at the other video, you get different ones. So that's the way I try to do it. But these ones are out of the book. My book. Substitution. This is the same as y, correct? It's y equals. So where can I put it? Right there. Yeah, I'm just going to, it's called substituting. Yeah? It's genius. So what I end up with is 2x plus 3x minus 8. And notice I have one variable now, because that is the way we like to do it. Go ahead and solve that. I'm pretty sure that Dylan is going to give us the answer to that question. Anybody else? Do you want me to? Should I just dot, dot, dot? Or do you need to see it?
No, we're good.
Okay. Now I plug in x to solve for y, right? So I'm just going to put it in the first one because that's easiest. And what?
Never mind.
That's good. This answer, 610, is also if you're asked to put it, put it. I'm putting on every one because I want you to see it. Okay, let's do are we okay with that? Why don't you just like take a mental picture of it. Remember it the rest of your life. Okay, let's try elimination here. Whoa, 3. That's because you're a gamer. Right? Yeah. All sorts of mathematical connections, isn't there? It used to could.
He plays Destiny.
I'm a little more into World War II, and he's a little bit more into old school, way old school.
Ancient warfare. Not many wait.
Okay,
Wait, let me finish.
we have to eliminate a variable.
Why? Eliminate Y first.
Why?
Because
One positive, one negative.
Okay, how am I going to do that?
multiply.
Okay, let's do that.
I was my time to shine.
They all get it. It's just lovely, isn't it? And then I'm just going to,
What's 1040 divided by 7?
I don't know, you're the math student.
Why'd you multiply it by 3?
To make the y's the same. So we have 4 and negative 4. Okay, am I going to add or subtract? Thank you for adding. Because 4 plus negative 4 is 0. So I get 0 y's left over. Zip. But 10 plus 3 is 13. And 1040. You did mess up. Shame on you.
Then we can put it in any other equation.
What's the y value?
80.
You put that into one of the equations, right?
Yep.
Y is equal to 3.
I've heard 30 and negative 30. Which one is it?
No, it is 30. My bad.
Yeah, quit being so negative. In this case, you might need to be negative. Which one is it? Survey says? Very good evidence that the force does not actually exist. Or that Mikey's very much incapable of using it. Take your pick. Consistent and independent. Again. Again. I will. I'll show you. I'll show you. Okay. I'll show you.
What's the other way of writing it? If it's not consistent or dependent, it would be.
I will show you.
Oh, okay.
By popular demand, I will change the script.
Why?
Consistent and dependent. This means they're the same line. So you're going to see the same slope and the same y-intercept. Yeah, like a genius.
Pretty much. I wasn't reading at all.
Okay, so you're going to see they're the same line. They have the same slope, same y-intercept. How many solutions are there? Infinite solutions. Okay. So that algebraically, this is a simplified version. If I subtract those two, same line, what do I get? 0 equals? Okay. That's true, right? 0 does equal 0. So the next one I'll show you is actually false, which is why I show it to you. That's what you get with consistent independent systems. So consistent, they get a solution, but they're dependent upon each other because they're the same line. Okay, it's called a cruel irony. Like my dependence upon you. Is that crystal clear?
Yeah.
Well, there's plenty of it out there if you want some, Mikey. Go take a bite.
Okay, I like to go slowly. You forgot it. I said fine. Come on, bud.
Hello, Kayla. I'm Earth. Welcome back. Are you with us today?
No.
Somebody's got a case of the Tuesdays. Parallel lines. I don't focus all my attention on you, just 90% of it. Are what we call inconsistent. So remember, same slope, different y-intercept. How many solutions?
0.
That's not possible.
21.
None of them. Yeah, because they never intersect.
Right. Oh, I so have to find that comic. One of my favorites ever.
Randy's birthday was
It's your birthday?
Yeah, that's why I thought they were 5.
You have a birthday? Huge.
Happy birthday, Randy.
Isn't it obvious? Every one of us in here had a birthday. Never mind. That was too much logic for Tristan. I had a birthday. I'm here. Woo! I don't know either, honestly.
It's a Russian.
You really make me question your life.
Okay, so let's finish here. Two equations with the same slope but different y-intercepts. I'm going to get something if I do elimination like that, which is a false statement, right? If I get some sort of a false statement, like 0 equals 10, I know that we have an inconsistent system with parallel lines. There are no solutions. Okay.
Wait, I have a question.
Huh?
So, how do you get to 0 equals -4 after that 0 equals 0?
That's the point of. So y minus y is 0, 2x minus 2x is 0. But -1 minus 3 is -4.
Oh.
So that means they're parallel lines. We have no solutions. In contrast, 0, 0, 0, that's true, which means they're the same line. So you either have the same line that has infinite solutions or two lines that never intersect, which is it happens in alternate universes all the time. By the way, here's a little sidebar. Did you guys know that there is a mathematical coordinate plane where those are parallel lines?
Wow. Let's not do that. Is it like a circle?
No, that plane is defined by vertical lines and half circles, semicircles. It's called the Poincaré plane. Just a little sidebar. Thank you.
So it's not relevant to what we're doing for home.
So the lines, So in the coordinate grid you guys are used to working in, lines are straight. You have parabolas and such.
Yeah.
Well, this one is defined. Every line is either a vertical or a half circle. That's it. Those are parallel because they meet the definition of never intersecting, right?
Yeah.
There you go. Sidebar. There's some college math for you. Do you want me to show you a word problem?
No.
So, okay, here's what I'll do. I will put the problems up here. If you want to ignore me and work, okay, fine. I give you permission this one time.
I ignore you all the time, so why would you?
If you want to listen,
I don't want.
It's a guy that's on the floor.
2.1. 1, 5 through 10, 32, 33, 39 through 45. Do Thursday because I'm nice. If you want a word problem, listen up. If you don't, shut up.
Wait, so after I do, are we going to be allowed to work on this and direct class?
You might have time tomorrow in class. I suggest you use the half hour I'm giving you right now to do it as much as you can. Okay, that was a hint. That was more of a directive. If you're going to work, be quiet, please. I'm going to show a word problem example. Okay, so I have the cotton. Guys, hello, Jose. Do you not understand the meaning of be quiet? Because I can tell you or I can show you. You'd rather me show you because that means I'm quiet. Thank you. Okay, so the Cotton Club manufactures sweatshirts. Okay, we have a fixed cost of $2,000. Variable cost $5 per shirt. Okay. We sell sweatshirts for $15 each. What is the break-even point? So obviously they have to spend money before they make money, right? So they've spent $2,000 plus $5 for each one they produce. They're making $15 profit starting at zero. So some point they're going to cross that break-even point. It'll look something like this. At some number of sweatshirts, they will break even at $0 profit. Okay. So if I write two equations, one for cost and one for money made, we can find that break-even point. So I would have $5 per shirt plus $2,000 for your cost, right? And for your sales, it would just be 15 times the number. If you can solve those two, you'll find where the number of shirts you need to sell to break even at $0. And any beyond that, you're making profit. So, anybody care which way we use? Substitution, elimination? Okay, let's substitution. What's my equation going to be?
Y is 16.
Thank you. Okay, so this here, put it in. Plug it in, plug it in. Okay, lame. X is 200. So we have 200 shirts to break even. That's actually not very much for a manufacturer. How much profit are they making, or how much have they spent? $200 times 15 is.
What did it be times 5? Yeah, times 5.
You get the same answer. You plug 200 into either one. 200 times 15 is 3,000, or 1,000 plus 2,000. So it doesn't matter. So they've spent $3,000, sold 200 shirts, but they have made $0 profit. Okay, because they've made 3,000, they've spent 3,000, $0 profit. How many sweatshirts do they need to sell to make a profit? Yeah, 201 sweatshirts. They'll make how much money? $10. Because they have to spend $5 to make that one extra shirt. They make 15 off it, right? $10 profit. So they make $10 per shirt profit beyond that. Okay? Is that okay? So 25 or so minutes you got to work. Considering the craziness of this week, I suggest you use it. Okay?